Gravity. If you are watching this video, you have probably heard of Isaac Newton and the story of how he was bumped on the head by an apple. This story isn't entirely true. In fact, an apple landed beside him, and that's how he began to think about why the apple dropped to the ground and not fell into the sky, or sideways. This curiosity led him to discover the fundamental force on our world called gravity. In this video, I will attempt to explain this fundamental force. You probably already know that all the large masses, such as the Sun, have gravity, and you would be correct. But the reason for this is due to Newton's equation for gravity, which I will explain in brief terms. Gravity equals mass 1 multiplied by mass 2 over radius squared. This complex equation can be broken down into simple parts. The two m's stand for masses. This essentially means the two celestial bodies. On the macroscopic scale, or in the universe, this could mean the Sun and our planet. This could also be our moon orbiting us. Basically, these two masses are just two different objects interacting with each other in space. The R2 stands for radius squared. This essentially is the distance between these objects. Newton laid the groundwork by proposing gravity in the distance between two objects that attract each other. This was later somewhat proved by the fact that all celestial bodies are attracted to each other with some degree of gravity, such as our planet and our moon, which both exert a small gravitational force on each other. This keeps the moon in orbit and our tidal waves. This can also be applied to smaller objects here on Earth. If you have two objects near you, you can imagine each as a small planet exerting a force on the nearby surroundings. Although this force is very small, it is still present and can still be measured. This fundamental force permeates all masses throughout the galaxy and throughout the universe. We may never know the true extent of this force, but we can keep searching in the pursuit of science.